Welcome all to the next section of Civil Engineering Drafting Lab. In this section, we are going to draw a reinforced concrete staircase. In this, we have to draw the plan and a sectional part of this reinforced staircase. So all of you take page 25 of your manual given in the Google Classroom. And this is a drawing number 6 of your manual drafting part. Okay, first before we draw the figure, we have to be familiar with certain terms of the staircase. And for exams, you usually get the question, not the figure for drawing. So we have to be familiar with the terms. That's why we can find the number of rise and thread. And rise and thread is the main part of the stair. Rise means it is a vertical distance between two consecutive steps. Vertical distance. We take two steps and the vertical distance from one step to the other step, top of one step to the other step is called a rise. And thread is the horizontal distance between two consecutive steps. We take a distance from this point to the next consecutive steps, same point. The horizontal distance from this point to the same point of the next step is called thread. For the foot placing width of a step called thread. And you have to find the number of threads and number of rise to draw a staircase. And the other terms are landing. Here this part of the stair called landing, or it is a horizontal platform. It is provided in between two flights or intermediate floor height or at the top of a floor height. And flight means a continuous series of steps arranged in one direction. Here we can see a series of steps arranged in one direction, and this can be indicated as one flight, and the other series of steps arranged in the next direction, and this can be taken as another flight. In between these two flights, a landing is provided. Also, we can call this top slab as also a landing. And here we can see these vertical lines or the steel or the mild steel balustrades, and this piping of 5 cm thick called handrail. The PVC piping is given. Then nosing. Nosing means this projected part of a step called a nosing. Before drawing, you have to find the number of rise and number of thread. Here we can see that the height of this first flight can be taken as 145 plus 12.5. So 145 indicates the height from this point to the bottom of this landing, and this landing width or the landing thickness can be taken as 12.5. And the first flight starts from this point to this landing. So we have to take this height for height of the first flight as 145 plus 12.5. Here we can take height of rise, which is given in the figure as 17.5 centimeter, and height of room, the total height of room is 285 from the top of the floor to the bottom of the roof, which is 285 plus 12.5, which is the slab thickness, and height of the first flight, which is 145 plus 12.5. So we can find the number of rise in first flight, which is 145 plus 12.5 height of first flight divided by height of one rise, which is 17.5. I get 9 number of rise. And the number of thread, which should be less than 1, or number of less than 1 number from the number of rise. Here we can see the number of rise 1, 2, 3, 4, 5, 6, 7, 8, 9. Also, the number of rise is 9 numbers, and the number of thread, you can count from here, 1, 2, 3, 4, 5, 6, 7, 8. And the ninth one is a landing, which is not counted as a thread. So the number of thread should be less than number of rise, which is less than 1 number. So the number of thread is 9, and the number of rise is 9, and the number of thread is 9 minus 1, 8. Then the second flight, and the total height of this staircase room or the floor to floor height is 285 from the top of this floor to the bottom of this roof, plus 12.5, which is the slab thickness. And we can see the rise ends up to the slab thickness. So the number of rise in the second flight, which is equal to 285 minus 145, or 285 plus 12.5 minus 145 plus 12.5, which is same as 285 minus 145, and divided by 17.5, which is the height of one rise. We get 140 by 17.5 as 8 numbers. And in the second flight there are 8 number of rise, and the number of thread should be less than 1, which is 7 number of thread. So we got the number of rise and the number of thread, and first we can draw the plan. We have to draw the plan, then only the section. First we draw the size of staircase room, which can be taken as 100 plus 50 plus 50, which is the width of the staircase room, and the length, which can be up to this level. We can find the measurement, and the remaining just extend this portion to a certain distance. So first we take this width, and throughout this staircase room surrounded with brick masonry or wall thickness of 20 centimeter thick. So you can provide this wall thickness as 20 centimeter. And first draw a vertical line, then 20 centimeter thick wall, and the vertical line, and mark this 100 centimeter width, 100 plus 50 plus 100, which is 250 width, and extend these two lines. Then take 100 centimeter from this point to this point. This 100 centimeter marking is given for the width of landing. The landing extends from this point to this first first step. The first step, the width is taken as 100 centimeter. And after that we can provide the thread width. The thread width is taken as 25 centimeter. Normally 25 to 30 centimeters the thread width. And the rise height is normally taken as 15 to 17.5 centimeter. Here the height of rise is 17.5, and also in this figure all the dimensions are given in centimeters. So you have to write in the title block as all dimensions are in centimeter. And you can take the scale. This 1:25. You can take a scale of 1:25 so that the whole figure should be properly placed in your chart paper. Otherwise, you can use the larger size of the whole chart for the drawing or the half chart paper. If you use half chart paper, take the scale as 1:25. Okay, first draw this landing width as 100 centimeter. Then draw the thread width as 25. We know the number of threads. Here the number of threads as 8 number of threads in the first flight and 7 number of threads in the second flight. So draw vertical lines specifying the landing first. Then draw the 25 centimeter width. Take 25 centimeter from this point to this and mark this line. Then again 25 and next 25, and we have 9 steps here. To this line we have 9 steps. 1, 2, 3, 4, 5, 6, 7, 8. 8 threads, and the lines, number of lines are 9, which indicates, these lines indicates the rise. This point, this vertical line indicates there is a rise at this point. Then the second line indicates the second rise at the point. And this width is given as 25. This dimension line is not this thread line, rise, indicating rise part of the step. So this one is only the dimensioning line, and this dimensioning part should not be given inside the figure. All these should be outside, placed outside the figure. If you draw these vertical lines, then draw the then take 100 centimeter from this point and 100 centimeter from this horizontal line. Then draw a horizontal line from the first rise line, and this piping width or the piping diameter is given as 50 mm or 5 centimeter. This handrail is 5 centimeter piping. So this width should be taken in scale as 5 centimeter. And this dotted line shows the beam. Here there is a beam at the top, and this beam is shown using this dotted line, and this throughout there is a beam exists. And if this first flight engages and turns the second flight and it moves to the upstairs, And as I've said, this vertical line shows the last step on the last rise line of the second flight, and this to this point flight ends, and this portion is a slab portion. Sorry, this point up to this point means last step or the rise line ends at this beam line, and the remaining this extends a slab portion so that the first step it was not visible in the plan. It was below the handrail and the slab portion. So this dotted line, also you can say this dotted line as the first step of this first flight. Here in this drawing, these three sides, wall thickness is given as 20 centimeter. Then the handrail starts from this point. The number of rise starts from this point, and the flight starts. And the direction is this V, and this line indicates the staircase direction, and move from this point to the upward. This arrow shows the flight ending point, ending portion. That's all about the plan. Next we have to draw the elevation or the sectional part. So we have to draw the section line first. First you draw this section line through this first flight, and here the section line cuts the first flight, so the section part is shown here in this first flight, so the reinforcement details can be seen in this portion. Then at first we have to project these dimensions, these lines, all these vertical lines we have to project. Then draw a baseline as the floor or the thickness of the floor. Then from that point, first we draw we have these vertical lines can be projected using projection lines. From the projection line, first draw the horizontal line. From that horizontal line, we can start the first rise. We know the first rise height is 17.5. Just using your mini drafter, you can draw this. In this projection line, you can mark this rise as 17.5. Then the second line, then from that 17.5 height, we can draw a horizontal line to the next projection line. Projection line extends from this line, and from all these vertical lines, projection line should be extended. Then first draw the 17.5 height, then draw the 25 width, then draw the 17.5 height, rise height, then 25 centimeter thread width, then rise, thread. That way you can finish this zigzag portion or the step outer shape maintaining part of this rise and thread width indication. Then at this point thread 17.5 should be marked, and this landing it should be extended inside this wall, and this up to this point. From this point to this point, the width should be 100 centimeter, and it extends to this wall for the firm fixing. Then width is taken as 12.5. Then from the top horizontal line. We can take a 12.5 centimeter width, then draw a line from here up to this. Just extend this line to this point. Then we have to draw this staircase slab. Here in this figure, we can see rise and thread width. Below this rise and thread width, there is a slab portion which is of width 12.5. That indicates from this corner point to the this slab ending line or the slanting line. From corner point to the slanting line, there is a width of 12.5 centimeter slab. So we have to draw this slab. If you finish this zigzag portion, we can join this corner points using a slight continuous line or the projection line. Then from that point or from that line, we can draw this slanting line. First join this bottom corners of the steps, and thus we get a slanting line. From that slanting line, you should take this 12.5 centimeter width. Just given in this figure, this drawing. First they draw this corner points, join these corner points, and from that corner point or the slanting line 12.5 centimeter, then draw the line, this slanting line. Then extend this slanting line to this point, then we can join the extension of these two lines here. And also this part here, there is a foundation part, so the foundation width should be provided. We can use this projection width as 5 centimeter. This projection, from the first rise, this width can be taken as 5 centimeter. Then this depth can be taken as 5 centimeter. And again, extend this portion. Not extend this width, this bottom width as 50 centimeter. 5, then depth as 5, then again width as 50. And this landing line extension, and from this 50 width, this point, draw a vertical line, and this extension meets at this point. And this sectional part is complete. And similar to this this flight drawing, we can draw the other flight also. Then the handrail height is given as 80, so you draw first the handrail height here as 80, then draw a handrail or the baluster height here as 80, then join this handrail, then draw balusters for each steps at the same point in the thread, or the same point I have to draw this balusters, otherwise it will look it will not be aesthetic. Okay, then in the other flight also you complete this rise and thread portion using the projection line from this plan. First draw the rise, then thread, mark the thread in the projection line, then draw the rise, then mark the thread, and it completes at here this dotted line indication. We can draw this beam portion. At the beam portion also there is a cut here, so the reinforcement details are given in this. And here the beam width is given as 20 centimeter width, and the depth from this bottom of the slab as 12.5 plus slab thickness as 12.25 as the bottom depth of beam, then 12.5 as the slab thickness. 12.5 plus 25 which is 37.5 is the depth of this beam. 37.5 by 20 by 37.5 is the dimension of this beam. To complete this thread and extend this portion, then draw the 12.5 depth, and then draw a line, and from this point, this rise line, this vertical line showing the rise, and take 20 centimeter width as the beam, and the depth as 37.5, and draw a beam, then this 12.5, then connect this to this 12.5 centimeter thick slab, and all this portion we can take this for the reinforcement detail we can give a cover, which means here we can see from the end there is a spacing is given for the reinforcement, which is called cover. This cover can be taken as 30 centimeter. Minimum cover should be taken as 30 centimeter, and this 30 centimeter cover should be given from all the sides for placing the reinforcement. Here we can see in the detail there is a dark line and the outer line. There is a gap between these two lines. This can be taken as 30 centimeter cover. Also from here also there is a gap between the reinforcement and the tile or the floor tile. This gap can be given as 30 centimeter. Also there is no need to provide this nosing and the floor slab, just you provide this sharp corners of this rack and RC beam, RC stair. No need to provide these nosings. You can use sharp edges. Then in this detailing there is a dropping bar called a suspender. These shape maintaining bars called as suspenders are given. Here the suspender extends to this main bar, this landing main bar of this landing bar given. So this suspender extends from this corner to this bar, and also there is a small dots given. These dots are the dots are the distribution bars. These are the distribution bar. This line indicates the main bar. Slanting line indicates the main bar, and above that slanting line there are some black dots which indicates the distribution bar. There also is at this corner also some reinforcements are given. In order to maintain that shape, this reinforcement should to be provided. Here in this drawing you can clearly see the reinforcements are given. how these reinforcements are given. First draw the main bar. Slanting line indicates the main bar. Then above that, draw the distribution bar as small circles. Then draw the suspender bars. As you already explained about that, as we explained in the previous figure, in the detailing figure, draw the suspender bars, the shape maintaining bars, then draw the corner bars. Also all these bar dimensions are given, but you have to specify these dimensions as detailing. But these dimensions of the for the drawing, you will not need to take these smaller dimensions, because if you take these dimensions, it should be very small, and it's just like small dots. So we need to identify the things in what shape and up to which length the reinforcements are there. So we specify the distribution bars as small circles, and the main bars are lines. These lines as main bars. Indications are given, and also there is a connection bar provided from this landing to this flight, and also from this foundation. Also a connection bar is provided. Then this main bar also extends up to this foundation and bends like this, and the connection bar is given, which is just above this distribution bar. Actually it is placed just above the distribution bars. So we draw this distribution bars, this connection bars, just above these circles, touching these circles, and also here touching these circles, and this extends up to this foundation part and bend like this, and also a connection bar is bent from this point. Connection bar is bent. Main bar extends up to this top of this landing main bar. Then bottom main bar of this bottom main bar of this landing extends to this flight, and which should be placed just above the distribution bar. In this figure, it is not such clearly shown in that way, but you have to specify the line which is placed just above the distribution bar. This bend up line is just placed above the distribution bar. Then the beam details. Then the reinforcement details should be provided at the beam section. And this beam dimension, we know this beam dimension. Provide a rectangular shape main bar, and the four corners there are some main bars are placed at the corners, and this rectangle shows the distribution bars. And the main bar from the slab is also extended to the beam portion for the proper connection, and the distribution bars are given as dotted small dots or the circles. Here we can see the rectangle in this beam dimension. Reinforcement detail is provided in rectangle shape. And this rectangle shows the distribution bar, and the dots or the circles at the corner shows the main bar. The small small dots in the slab indicates the distribution, and the main bar, which is extended to the inside of this beam. Okay, that's all about the reinforcement details. And this wall thickness is 20, and here a window is placed, and the normal window marking should be given here. Okay, that's all about the RC staircase drawing. You have to draw these two figures, plan and section of this RC stair. No need to draw this detailing and all. Here the reinforcement details are much confusing, so if you have any doubt, you just call me and clear those doubts, and the drawing should be specific for the reinforcement details. The reinforcement details is very important. Here in this drawing, overall view of this drawing is given. You can see this in 1:25 scale. It can be properly arranged in the half chart paper. And the drawing should be placed to this chart paper. If you use the full size chart paper, the drawing dimension or the scale can be increased. You can use 1:10 or other scales. Okay, I will try to conduct one class or one meeting for this drawing. Before that, all of you should see this video fully, and not all those doubts and should be cleared in that meeting. Okay, thank you all.